Thank you very much for the introduction. And indeed, this is my second talk, and I'm very happy to be with you and the group, certainly. And let's see. Thank you very much. First of all, as a reminder, my background is mathematics. I'm not a hydrology background, but I learned a lot along the way. And also, I focus on the learning algorithms. And this is a work, our group work. And so this is one of the components from the Franz Mayer project. So I will get into the details. I have lots of slides. I will try to cover as much as I can. And my goal here to give you a general view of where our deep learning algorithms are and see where we're going to go next. But before starting, I just want to kind of touch my last Nepal visit. I think it was a wonderful visit, and I had the opportunity to get together with the ECMOT group, and also we went to the north of Kathmandu and see in place basically how the landslides are happening. And you can see the top image there. This is a panoramic view. ECMOT group, Mickey, and all of us were there and basically investigating the area. Those are some of the pictures we took along the way, and as you can see, there are lots of landslides, and basically we get to know all these areas in person, and you can see it through the Trishuli River. We went up to north and saw lots of interesting landslides, and as well as the water flows. And the second part, our trip wasn't only along the Trishuli River, but also we get into in the Kathmandu area, especially look into the floods, which is basically what I am doing for this project. And as you can see, the numbers, over 200 people die and lots of problems. So it is extremely important. All the pictures, by the way, is taken by us. So it's extremely important to put proper algorithms to have the early warning and other related issues regarding to the floods. So this basically tells you why. And the project we are working on is not just started. We already have a product out there, and Franz Mayer and his team put together an incredible product out, and with the automated pipeline, everything works automated, speeds up the flood map generation and so on. And as you know, the project uses the synthetic aperture radar, which can see through the clouds. This area is always lots of smoke in the area and the cloud cover, so it's extremely important. And so let's continue. As a continuation of their project, this is the second proposal. What happened is that how we can improve their current products with the deep learning algorithms, in my case, especially for the flood-related activities. And if everything goes successfully, this will end up with a new product, which is called Hydro-SAR NG DNX30, and so that NG is the difference there. And so what is our approach? First of all, let me go a little bit general view. As you can see, this is the development of operations, especially for the deep learning algorithms to be implemented in a big system. So the first step is basically model development, and after that deployment comes, and we go to the operational. So currently we are working heavily on the model development, but also in the deployment part, we are looking into the verification, model verification, and the automation. So, for example, we have the first examples of the automated retrieved parameters and so on. So basically, we are slowly getting ready once everything is finishes, to implement the components to the operational the operational site. And I purposely put so many different value of data engineers has to be there, and the data scientists and many other groups involved with this. So it's a whole process by itself. So basically, what happens is that in our approach, we consider two different cases. Our goal is to create a product, daily product, which will help us to see the current flood conditions. And so what happens is that if you look at it right upside, data frequency are different. So for example, a processed SAR images come 6 days or 12 days with a different time scales. In the meantime, we are promising daily products. So we need to come up with a different way to support these RTC images. So the basically approach two ways. One of them, if we have the SAR images, then process that and get the segmentations. And the second one is if we don't have the SAR images, use the other components, like in this case, HANS, which is elevation maps, spatial elevation maps, let's call them. And we use river stream anomalies. So this will be probably expanded to the rain amounts and so on, precipitation. So now I'm going to give you the summary of these two approaches where we are. Now, this is the current product, how the current product works. SAR images and the digital elevation creates the RTC images. There's an automatic threshold. I will not get into the details. And at the end of this process, water masks created for the given image at the time. So if we go one step up, what happens, you see on the left side, one example of the input image, and at the bottom, you can see the label for that, meaning that water mask. So this is basically created with the first Hydro-SAR product. So the idea here to use these current images, which are created already, and it has a solid background, and push these things, use the water mask like a label, and also images, and push them through the machine learning model and basically train. And after that, get the learned parameters, which is the online process, as you see on the right-hand side. And for the new SAR images, just get the flood estimates. Basically, this is a very simple flow of the whole system. One thing we observed that sometimes it might be underestimated. By the way, this is under study. So we are studying very heavily on this part to understand better. So, but it seems like it's a little bit underestimated, some of the water masks. So what we do is that we get the regular water masks. So first we are working on the labeling of the problem. We feel like it's not complete. Maybe we can improve somehow. So we are working on that. And as you can see, we are taking the regular water masks created by the Hydro-SAR, and plus we are rerunning this product through a also mask and creating the each digit assignments as a water and no water. As you can see, there's a big difference between two. One of them is overestimating, the other one is underestimating, or something similar to that. So we look at the difference of that, and after that, we run a random forest algorithm, which looks at the nearest neighbors of each structures on these differences, and creates a new mask for us, which is almost in between these two. And so basically what we did, we used the uncertainties to create this new mask. So after this point, we use only this mask for the training purposes. So let me go back to this. So this is the what we have currently. Left side is the original RTC image. Right side is the created mask, which is all improved in terms of the capturing some of the textures in the image. So the flood has a very specific texture in the SAR, and this is capturing that information, basically using the earlier estimates of the labels. So what we do, we feed this data, newly created labels and the images into our system. And there's a lots of pre-processing going, by the way, before doing that. So I just put an example here, which is, as you can see, almost 7,500 by 10,000 pixel images we have input. So as a first step, this is a very big image to process, first of all, for training. What we do, we create patches. And I put an example of patch here for the image as well as the label. And after that, we filter these patches one by one, and we look at if there's a water in it or not. So if there's no water at all, we just eliminate that. And we split the data, trainings 0.75, 0.25, so that we can basically validate properly. And we do other things like organizing the director structures, and also we augment the data sets. Once we have all the patches, we go through the TensorFlow image data generator and flip them and do lots of other things, and so that we will have enough number of images covered with the different shapes and the maybe light illumination and so on. So we are talking about 50 images, for example. First trial we did, each created 1,100 patches. 50 times 500 gives you about 5,000 patches plus the recreated generators. So we are talking about like 15,000 plus patches to train. And this is not a final, by the way. This is just, as I told you, the beginning of the problem. It will be much more images when it's available. So the model we are using to train is UNet model. This is a very specific model, especially works for this, each pixels. It can do the masks, segmentations precisely, actually, if you have a good data given to it. And the UNet model is specifically focuses on the pixels. So whatever you give, that is what you have in the model itself. So I will explain a little bit later more why I'm emphasizing that point. And the UNet model, without getting any details, does the training with the given data sets. And let me go to the next one. So now this is the updated flow where the UNet model is. And this is all the training and the validation steps, what is going on. One of them is intersection over unions, and the other one is the validation loss. As you see, it's just straightforward. There's nothing special about this algorithm because data sets are, I believe, quite clean. So it doesn't create uncertainties and so on. So it just approaches very quickly. And this is some of the examples after the UNet application. This is on the patches right now. As you can see, the testing image on the left, this never get into the training process. They were separated. And as you can see on the middle, since we have the control on it, testing labels, and on the right-hand side, it's quite close to the actually testing labels. Actually, even sometimes better, because if you can look at it, the label doesn't show the whole river, but the prediction on the test image began to give you some more information on that river, specifically in this area. So I'm gonna show you very quick several results out of that. Now I show you the patches. Actually, what happens at the end, that patches again comes back and we unpatchify them, and they create the big image and began to look into the details. So over here, I just tried to show you where is this area and where the image is. So I'm going to focus on some of the parts and show you the differences between the original Hydro-SAR and the deep learning estimates. Now, this is the focused version. I hope you can see. I think river paths are very clearly seen, and this is the original Hydro-SAR estimate. And if you look at it, just the middle parts, all that gaps now filled in the deep learning. So this last one is the deep learning version. So I try to put patch mask or augmented images at the file name. Very similar, but just telling you that that's the deep learning. Now I'm going back again. As you see, fill the gaps, but the rest of it is quite similar. And let's do another one. This is a little bit more, how we say, complicated case. If you look at the SAR image, again, you can see a lot of details. And this is the Hydro-SAR, and this is the deep learning. Now, as you can see, there's a big difference in both. And currently what we are trying to do, Minjan Jo, one of our co-Is working all together with me, try to see how we can validate this information. So we need to figure out which one is closer to the reality. So this work still continues. And this is the last example I'm going to show you. This is from the OpenStreetMap, by the way. I want you to look at these areas. And this is what is shown. And as you see, the difference between the two images. This is one of the major problems in this area, that the riverbeds continuously changing. And that means the maps we have for the hand also needs to be updated more often. So, for example, from this trip, clearly we saw that. And over here, when I came back, I look at it specifically if I can find the image for this. And there it is. And this is the Hydro-SAR. And I'm going to go to the next one. And this is the deep learning algorithm estimates. So, as I mentioned, the still study continues for the validation purposes. And the ICIMOD group is helping us to get the closest and independent validation resources, not how we say their sources. So we'll see how that's gonna go. So as you can see, it's underestimation. Earlier we talked about it, overestimation with the also, and now we have a middle point, and that middle point basically giving results that we need to verify them. We can use also optical images when it is available. Now the forecasting early results. This is very early, by the way, and we have to be kind of cautious when we are giving them. So this is the current model for the unit. And what happens is that, again, I'm going back to this data distribution. As you see, like second, third, it doesn't have the RTC images. So what we need to do, we need to kind of approximate that in order to forecast this. Let's say our time is here. We want to know what is going to happen next 2 days, 3 days. It can be do forecasting or backward as well. So what's going to happen here is that we don't have the SAR image, but historically, to train our system, what we're going to do, we're going to take the GeoGlows data. This is the stream flow of data, which I think version 2 right now is the updated version. And we're going to take also the hand data, and we will create a combined GeoGlows hand data. Let's call it, I will call it cost function. This is kind of question mark, but you will see why I'm calling that way. And we will basically train this system now and using the segmented images. But when we come to the online process on the right-hand side, we will remove the segmented image because we don't need anymore. Just our inputs will be GeoGlows and the hand data. And that should work with the learned parameters. But UNet will not do this, right? Because UNet is very precise, concentrates on the pixels itself. So what we need another method which will, instead of concentrating on the pixels, it should kind of concentrate on the distribution of the data. So this is where the generative AI idea came. By the way, this is the first thing we apply, and now I'm going to show you the results very quickly, and hopefully we will have some discussion at the end. So now we are kind of moving from UNet, not fully, but wrapping that UNet with the generative AI where the distributions are considered. So what we have on the left-hand side, we have the hand matrix. In the middle, we have the, I call it augmented matrix because we did a little bit change on the size so that patches will work. And on the right-hand side, anomaly matrix for the river flows calculated from the GeoGlobes. So those are all z-scores, by the way. I believe I mentioned that in my first talk. So the yellow, it's a little bit higher than usual water flow, and the blue is just a regular one. So, by the way, paper will be published around March for this. So I'm not giving you too much detail, but certainly I will share the paper with the once it's published with Tim so that he can share with you. And this step is a kind of, maybe there's out there, I didn't see too many of them, but what we are doing, using the hand cost functions and what is called river flow cost functions or matrices, and combine them. So as you can see, each of them has their own weights. The details will be given. And finally, we come up with the images at the bottom. So what this image tells you, the blue, very blue parts, there is no possibility that it will be any flood because it's too high, that areas, or maybe there's nothing related to. And but the more red it gets, and you will see more possibility that if there is a big precipitation event or change in the flows of the rivers, this will be the how we say areas might get flooded. So now instead of the image, SAR image, we are began to push these how we say images and giving under the changing GeoGlobe data anomalies. So this works actually turns out okay. And I'm gonna show you the results. Let me go to the next one. So generative AI plus UNet combination in the patches began to give okay result. And we are basically capturing some of the patterns that it's very interesting. It's just coming out. And the input image through mask, predicted mask. And so there are overestimations, certainly. We have to be very careful with the generative AI. I do accept that. And so, but the point here that we began to capture the all these patterns. Now, there is another study going on. We are using also diffusion models to do similar techniques that will be also in the paper, which I didn't put it here. So before going further, as I told you, I just want to give you the flavor what is going on so far. I think we are very comfortable with the UNet. The only thing we are trying to understand are labels really representing the floods at the time. So a lot of validation efforts is going on. I put in the bottom, Minjan Joe works on these subjects independently, and certainly we will come up with the best result possible. And the second one is the forecasting. Still, we are continuing to work on that, and but we have some okay results, which are encouraging us to continue in a similar fashion. And certainly looking to the additional algorithms, we are exploring them. And one last thing I really like to emphasize that when we are doing all these studies, uncertainties is extremely important. And what kind of uncertainties we are introducing to the system, how we can track them. So we have a parallel study trying to understand how the uncertainties is changing depending on the land conditions and the other components. Well, I will stop here. I hope this gives you a general idea where we are. And certainly, we don't want to see any disasters. And I have to say, Nepal is one of the most wonderful countries with their architectures, with their foods and everything. And hopefully, we will be implementing all these early warning components so that we will all together protect this beautiful location, as well as all other places similar to this. Thank you. Tim, I will leave it to you now.
Wonderful. That was so fantastic. Thank you so much. And I love your final photos of some momos. Like, talk about winning over a crowd with some momos. Awesome. Yeah. We've got about 20 minutes for some questions. So let me just open it up to the floor here. If folks have some questions, feel free to raise your hand, and I can zoom back and forth in the participants here. Give it a minute. As folks are formulating, I've got a quick one right off the bat. So I see like the value of just the upstream element of the original Hydro-SAR with the RTC products and how that's such a high quality SAR product relative to some other examples. So I think it's really exciting, like fully leveraging it. And in your UNet, the first element or the first phase of your slides, you talked about laying out a plan for validation. And I was just hoping to maybe pick your brain a little bit more on what your plan is for explore. Are you looking to maybe explore past known flood events with high resolution imagery to do some sort of confirmation of the UNet, and then also building confidence into the generative plus UNet approach? Or do you want to primarily focus on just the generative work? And what's your plan for the validation?
So one of the very nice thing about my trip was Mickey and the rest of the group, we were able to talk to a lot of people there. And so especially for me, one of the biggest interest is that I really believe that what we see in the ground, it is extremely important. For example, we talk about flying drones after an event and try to see if we can collect data this way. And I don't remember his name now, with a professor from the university in Kathmandu. They mentioned us that they are collecting data sets when the events happen. So we are in touch with him, especially for the, I would say, if any event happens, and also earlier events. And another thing is that the nature of the streams, how the water flow goes through, my understanding is that there's a threshold that if you hit that threshold, that is actually creating the landslides. And I'm wondering, how all the components can come together. So the traditional way to look at it, if we can find the optical images, that's perfect. We have something. But I really think that we need to support this data from the, ground, I will call it. Mm-hmm. I really think that is very different. And let me see if I can find that. I show here. Now, next time I can focus these images. It's very good to know how flat these areas, for example. And this has 2 or 3 drainage points, which is almost, such a big area with 2, 3 drainage points. It's just a recipe for disaster by itself. So I think it will be really great to have this kind of validation data with the effort of EC mode certainly, and our high resolution images, which I do look at Maxar and all that, whatever is available at the time. And so I hope this answers your question. So it is a very, very important part to tune the models. Mm-hmm. Otherwise, I think we will never able to tune perfectly.
Yeah, that's really insightful. And I know like in the past, we've relied on Planet and Maxar to construct these types of validation sets, but I think you're dead on of incorporating some of the university data because they're out collecting a lot of this information. So that partnership, I think, is going to be really, really valuable. And also, let's see here. I was actually really interested in if part of the paper, if you're planning to, I guess, structure the analysis to look at different slope profiles, because I know as you quickly leave Kathmandu and you head further north, the topography changes drastically. And, like what's the efficacy that you're seeing perhaps across different gradients of slope? Because I think that could be really valuable as well. And I know that's maybe your original challenge of Hydro-SAR in the first phase. And I just wondered if that's, obviously people live in Kathmandu, so that's probably the priority, but I'm interested on the methodological perspective.
Yeah, actually, when I mentioned to you, how to say implicitly, I talk about the uncertainties. Actually, since you ask now, the angle SAR is looking to the ground and analysis of, it is corrected, right? As much as it can be, but it will be really good to see more details on that. So one thing came up during our validation process. Many times deep learning captured very good, but there are some, image textures, let's call them, that looks like very small areas, overestimating maybe. I'm saying maybe because we really need that validation data. And so why this is happening? Is there a connection between the slopes and all that other types of information, which doesn't apply to Kathmandu, but maybe for other places? I don't know. So that's certainly an interest to look into. And by the way, it is already in my notes, all that. So hopefully we will have a small 1 or 2 paragraph in the paper on that.
That's fantastic. Yeah, I think Anastasia, hopefully I get that right, Anastasia. I see you've got a couple questions. Feel free. Just go ahead and hop in.
Hi, yes. I just wanted to ask if there are additional stakeholders involved in this research, any local agencies or disaster response teams, and if and so how they use this work for decision making.
Well, thank you very much for I will go back to my visit to ASMO. So we had 2 parts in this meeting. The part 1 was we were in their center, and basically I gave 2 talks there. The participants were from the Nepal government. There's hydrology department and different departments who will be involved if any disaster happens. So we had an extremely nice exchange with them. And certainly we exchanged information too, and they mentioned that at the time, how they can provide some of the data to us. And so it was a very nice exchange between the groups during this meeting time. And the university people I mentioned earlier, actually I met with them in this meeting. So what we have done, all of us, Nikki, myself, and we had Alaska group as well, representatives, table by table, and we collected the worries, we collected the questions, and how we can improve. So this is going to be published as a report by EC Mode, by the way, and I'm sure they will share with us, and I will make sure that we share with you once it is out there. So it was a very good exchange of information, I will say. Thank you.
Fantastic. Thank you.
Yeah, over to Kunsanong. Good to see you, Kunsanong. I see your mic is open, but I can't hear you. Let me scroll down here. Okay, so I'll just read aloud what Kunsanong had put into the question, into the chat here. The floodwater level in the mountain areas are very dynamic and destructive in a short period of time, like 24 hours. What does the model capture? Is it the peak flood period or the possible water? And I think he was also asking about flash floods in mountain areas versus flash floods in plains. I think it's kind of the question I asked as well, but maybe more on the temporal aspect. With this forecasting, are you looking at full 24 hours from the GeoGlows Plus? Are you forecasting to a single hour? And I guess that's also a user decision kind of question as well. So maybe a little bit more, if you got a little more thoughts on that.
Sure, I will. As you mentioned, it's a very difficult problem. First of all, we have to accept that there's a difference between the flash floods and the changing river flows. It's a difficult problem. Now, in terms of the estimations, at least this code is very dependent on the GeoGlows in one sense. And we can go up to 7 steps, 7 days. And at least this is what we are looking right now to see what will be the forecast on the 7 days. Now, I have to again emphasize here that it is very GeoGlow dependent. However, when we are improving these codes, this is something also we discussed during the EC mode meeting, is that let's say Nepal government has the water gauges, or they are able to provide additional data but consistent data. It will be very easy to train the system depend on that real time or near real time data flowing in addition to the GeoGlows. Now, that will be the very fast training, because what I didn't mention earlier is that we use backbone for the UNet system, meaning that we don't train from zero everything. So what we do in this case, for example, the results I show you, ResNet 34, which is a 34-layer CNN algorithm or CNN-based algorithm, which already has the trained models, and we use the transfer learning approach. So going back to the question again, if there is a data coming from the local, let's say, government resources, we can replace the GeoGlow, or we can augment the GeoGlow with data and retrain the whole system and create a new operational product. So question to that, whatever the result we get will be depend on the GeoGlow, and it is success. It's if it's good or bad, it's kind of GeoGlow dependent. Again, but we will be able to improve that very quickly. All this training takes very short time, by the way, because we are using these backbones. In matter of hours, actually, if the data is in the correct format, we can adjust to the new area, that local area. So that's, I hope it answers to your question.
That's fantastic. In fact, I was putting a note down here about incorporating DHM or FFWC's stream gauge data, reported flash flood data. So that's, I think, hopefully answered Kunsanong, but that's also, I think, an interesting aspect. And one quick aside, you brought up the topic of this flexibility of the model and being reliant on GeoGlows, but also being able to incorporate this new data. Have you guys explored, and I always have the strong advocacy for the current tool that uses HiWatt, the flash flood SBT tool in Nepal. I know the total accumulated precipitation is generated daily and hourly. I don't know if you've explored that with your collaboration with ECMOD, but that might be a valuable tool to give some of the total precip for this model.
So there are several things we are exploring. One of them is certainly high watt. The precision of the rainfall, I was amazed with that. It seems like a little bit problems with the historical data, which, as you can imagine, for machine learning, that might be the case. But maybe from this point on, we might begin to think on that and try to create a next, let's call it a monsoon times, we can maybe create the data sets and apply that to the model, which will be, again, very quick, by the way. So think like we are pushing only one GeoGlobe layer. Now we're going to push 2 by GeoGlobe levels or something like that. I don't know. But certainly that might be another very good product to consider. I really like the precision and the resolution of that data set. The second thing we are looking is actually improving the hand data. I know that France is always working on that. There are lots of communication is going on, and they have already new resources which back and forward we are trying to understand, how we can use that. But also, let's say you created a very high resolution data. There, let's say Nepal government has something like that, doesn't want to share. The system has to be able to handle that new data without the intervention from outside. So maybe we will begin to think about that too. So these 2 subjects is very important. One of them is the high watt, and the other one, the renewing the hand data as often as possible because of changing conditions on the ground. So, yes, to your answer.
That's great. And I'll pause here for any more questions because I do have one question more on the hand as we're on that topic, but I feel like I'm dominating all the questions. So I'll pause here for others if there are any. Feel free to raise your hand. The question I had about the hand is, are you guys currently using the Copernicus hand product?
Right, yes.
Okay.
But I'm looking into others. I'm trying to, one of them is like PubDem, I think. That is, we use PubDem data for finding out, especially for fires, finding out canopy height and this kind of things. But I think it might be used here as well. Certainly, we're going to look into that and some other data sets, if possible, with the high resolution. Yeah.
Nice. And did you do, when you're exploring both the UNet and the generative AI plus UNet, did you incorporate any feature engineering into covariates, or are you letting the model sort of identify valuable covariates? I think this group in particular has spent a lot of energy in the past doing a lot of feature engineering. And I think now maybe the tenor has sort of shifted and letting these deep learning algorithms sort of identify those relationships. So I just wanted to know where you stand on sort of the production and operational stance of, feature engineering.
So I'm a kind of old-minded person. I like the deep learning and everything, but still I heavily believe that the feature engineering is extremely important in terms of the explainability of the systems. Now, when you run the deep learning algorithm, and if you're going to give a decision, right, you have to be very careful. All these deep learning algorithms has to be surrounded with a components which will explain why the system took that, classification, let's call it. I don't want to say decision, but because some of the classifications can end up with the decision. So explainable AI is extremely important. That tells you that in some points, you need to look into the feature engineering. That is my, thinking. Because to be able to explain some of the pieces, we must know the features, how they came,
Mm-hmm.
It's not only the edges, right? Like UNIT and the CNN, they look at the edges, maybe some other like changes, then you can capture them. Actually, they are all the matrices they are defining in there for the convolutional matrices is that similar idea to features. So there's nothing special there. But I remember a long time ago when we were looking the how you say patterns, we run maybe FFTs, right, and maybe some other things. So my answer will be to you. I think deep learning doesn't need that in new feature engineering, but as a group who involves with the disasters, we always have to be aware of the system explainability requirement. By the way, this is US government requirement too. I can share with you that. And they keep the things in balance. Let's put it that way.
Yeah, I feel like that is a fantastic answer because it really talks about the capability of technology, but the responsibility of to be good stewards of the science and the knowledge. So I really appreciate that perspective. We've got a couple minutes left, and I'll pause for just a few more if we have any more questions. And I just want to say thank you so much. I'm so excited for this research. I know you guys have been working hard on this. This is the second AST project in the area. So there's a lot of opportunities to really embed this technology and this solution for the long term. The door is wide open for any time you want to come and give another presentation. I'll bother you if you've got more cutting edge stuff. And please do share the paper when it's published. I think this group will really be excited to read it. And maybe we can time it with another presentation or something like that.
Thank you very much. By the way, I will look at the book. If you don't have the self-learners part, I can contribute on that. I don't know if you have it or not.
Okay. Well, yeah, we'll talk offline about chapters because we're in the, as you know, we're in the hurdle of getting the first cohort out. It's all going to be published through the NASA TRS system, so we've got time. So if you're interested, the door's wide open.
Perfect. Thank you very much one more time for the invitation.
Of course. Thanks everybody, and we'll talk in 2 weeks.